This presentation, I'll be looking at the ubiquity of TWP and its impacts on terrestrial plant ecology. Now, in today's presentation, I will fragment it into two. The first one will be on the ubiquity of TWP, while I will now look into the effects of different TWP in terrestrial plants. Firstly, how are tires made? We have natural rubber and synthetic rubber. The natural rubber is made from the rubber tree, which contains some components such as the isoprene, which is about 90 to 95% constituent. We have the protein, which is about 2 to 3%. We have the carbohydrates, which is about 1 to 0.5%. We have the alkaloids, which are also a fraction. Then under the synthetic rubber, they are mainly produced from crude oil, from natural gas, or from coal, from countries like the United States of America, the Japan, China, Germany. Also, countries that are crude oil producing countries, for example in Africa, have the propensity to produce this synthetic rubber, because crude oil is the major raw material for synthetic rubber. When it undergoes refining to give the naphtha, it will now undergo steam cracking to give ethylene or propylene. Then during polymerization, we now have the synthetic rubber. Now, there are some pros and cons between the natural rubber and the synthetic rubber in tire production. For example, the natural rubber has high durability and reliability, similar to the synthetic rubber but with different disparity. Then also, the natural rubber is more environmentally friendly. But when it comes to degradation, the natural rubber is prone to oxidation and degradation. Other components include the carbon black for the strength, and which you can also, we have the silica, which helps it to grip even during the wet condition. We have the sulfur, which acts mainly as the vulcanization agent. We have the steel for the skeletal parts and for the strength. Then we have the antimony triazide, which is mainly used as the fire retardant. Then after that, we go to the next step, which is the vulcanization. Now in this process, the molder is heated where sulfur takes its work. Then we have the last one, which is quality check, where the rubber produced are checked by the manufacturers for stronger quality. Now, according to Yan et al. In 2021, they have the formation mechanism of TWP. And in this formation mechanism, they propose that the micron-sized particles are formed during micro vibration. That is to say that every car has micro vibration, but might not be detected due to the shock absorber in the car. So to every micro vibration, there is a micron-sized particle emitted. And for every small crack developed from high vibration, that's to say that if there is a high vibration in the car, there is a crack. And the slit movement, which is called slit oscillation, which is also regarded as the to and fro movement or reversible movement, causes the crack, which is produced from the high vibration, to increase. Also, according to Schwann et al. In 2017, they proposed TWP scattering using the Lagrangian method. And in this, I summarize it into 2 points, that at 60 millimeter from the tire, 10 micrometer particle reach 170 to 250 millimeter in height. And the scattering takes place with the radius having no effect. So whether you are using high torque or low cars, the radius of the tire has no effect on its scattering. In a study by Song et al. In 2024 on the topic defining primary and secondary microplastic, they defined primary and secondary microplastics. From their definition, I coined that TWP is a secondary microplastics because of 3 points. The first one is they originate from tires. Secondly, they are broken down by frictional force or abrasion. And the tires, the particles, enters into the environment as small particles. This is the point where the ubiquity comes in. From there, we now have a study by Kazmi, which stated that these particles emitted can cause gene mutation. Gene mutation being the permanent change in DNA sequence of a gene. And not only that, we have the protein modification, oxidative stress, metabolic disorder, and energy imbalance. And all these are found more in school children. And this is because the time school children are going to school and the time they are coming back from school, they are the time we have much traffic and we have this emission of TWP from tires. In our study, we have the pathways of gas particle partition in TWP, and we mentioned heterogeneous chemistry and transformation as a reversible reaction to GPO. In environmental science, heterogeneous chemistry and transformation is a chemical reaction involving the change of different phases. In this transformation reaction, we have solid to gas transformation, example is catalysis. We have solid to liquid transformation, example is dilution. We have liquid to gas transformation, example is aerosol transformation. Now, in the ubiquity of TWP, the heterogeneous chemistry goes into the catalysis, which can be oxidation, pyrolysis, or gasification in the presence of a catalyst to speed up the chemical reaction. And the catalyst can include platinum, palladium, copper, iron, and others. Now, the reversible reaction gives the gas phase oxidation transformation products. And I conclude by saying that in GPO, gases react with oxidants forming transformation products, another part of ubiquity. Summary of key points. The first one is that the atmospheric MP have both terrestrial and oceanic sources from the emission. Like I said earlier, the emission can be as a result of bubble bursting or sea spray. Naturally aged TWP show less toxicity as compared to pristine TWP according to the second study I presented. And lastly, tire manufacturers and school children are more at risk of this TWP. And the question here is, as for me, as an environmental scientist, I can say that the use of nose masks for school children, in fact for everyone, should be mandatory.